Guys, welcome back. We're going to go through the next page now, which is actually page 6. I don't know why I've written page 5. Okay, so we've got two similar rectangles. Find the area of rectangle EFGH, so the second rectangle here. Okay, so hopefully this will show us something interesting. So let's find the scale factor between the two corresponding sides, and that is a nice big obvious 3. And therefore we can work out this length here. So 7 lots of 3 would be 21. Okay, so the area of the second rectangle is 6 times 21. And that is 6 times 20 would be 120, 126 square centimetres. Okay, now let's look at the area of the first rectangle. 2 lots of 7 would be 14 square centimetres. So what's interesting here is that the area scale factor is not just multiplying by 3. So some of you may have been tempted just to find the area of this first rectangle and times it by 3 to get the area of the next rectangle, but that wouldn't have worked. And we will go into more detail about that later on. But how many times does 14 go into 126? If we do 126 divided by 14, we get 9. Okay, so it goes into it 9 times. Right, well, what's 9 got to do with the scale factor? Some of you may spot the connection. The scale factor squared gives us the area scale factor. Okay, and we'll spend more time looking at that in a bit more depth later on. Okay, find the size of the missing lengths on question 6. Now this is a different way to present similar shapes, but they still are similar shapes. We've got a triangle embedded within another triangle here. And we know they're similar shapes because both triangles obviously share this angle up here. If you remember from the previous video, I said if we can prove that the angles in the shapes are the same, then we know they're similar. How do we know that this angle is the same as this one? Well, it's to do with parallel lines. Okay, the fact that these two lines are shown to be parallel means that these two would be corresponding angles and therefore equal. Okay, so I'll just put a double angle thing around there. And for the same reason, these angles here are also equal. Okay, corresponding angles on parallel lines. What I like to do with these questions is actually just separate out the smaller shape from the larger one. I mean, you can draw the whole thing again if you like as two separate diagrams, and it might help. Try to draw one a bit bigger. Okay, so here's my smaller one. Got a length of 6 there, a length of 8 there, and K here. And on this shape, I've got an overall length down here of 12 and an overall base of 10.5. Okay, and these two are my corresponding sides that I can get the scale factor from. So what do I times 8 by to get 12? I times it by 1.5 or 1.5. Okay, remember you can just do 12 divided by 8 to figure that out. So if I want to know K, let's go with K first. I'm going to divide this by 1.5. And that would give me 7. And the final one I want to know is J. Now, to do that, I'm going to figure out the length of this whole side here. So I'm going to times this by 1.5. 6 lots of 1.5 would give me 9 centimetres. So that means J is 9, take away 6, so J is 3. So K was 7 and J was 3. Okay, and they love to present similar shape questions in this style. Just draw out a bit more knowledge. Okay, number 7, another way to represent similar shapes. How do we know that these two triangles are similar? Well, what do we know about these two angles? They're vertically opposite. Okay, therefore they're equal. This line is parallel to this one, which means that these two angles are alternate angles, and alternate angles are equal. And similarly, these angles here are alternate as well, so they're equal too. So just another way to show that these two shapes are similar without even telling you in the question. Now, what this poses is a kind of extra level of difficulty, I guess, in that the corresponding sides are, this one corresponds with this one, okay, because these are the sides between the angle with the single arc and the double arc, and there's the single arc and here's the double arc here. So these two are my corresponding sides, and that's how I'm going to get the scale factor, times by 3. Okay, so if I want to know m, I'm going to divide by 3. So 12 divided by 3 is 4. And n, I need to times this one by 3. And that will give me 13.5. Okay, and number 8, similar to number 7 in the way it's presented, one triangle embedded within another one. I'm going to draw them separately again, pretty badly. Okay, so this is 6, and that's 10. This is 12. Okay, and I'm not going to add anything else to the longer shape just now. So this is what I'm going to get my scale factor from. What by times 10 by to get 12, so what's 12 divided by 10? That'd be 1.2. So 6 lots of 1.2. Would give me 7.2 as that overall length. And then I've got to take away 6 to be left with Q. So if I take away 6 from 7.2, Q is 1.2 centimetres. Oops. Okay, I'm going to write an equation for the last one. So that length there is P, and this length here is P plus 1.6. Okay, we'll see where this goes in a second. So I know that if I times P by the scale factor, 1.2, I get P plus 1.6. So I'm going to write that as an equation. How would I write down P times 1.2 though? Well, I would just write 1.2P, and that's equal to P plus 1.6. And then I'm going to solve this equation. We've done plenty of this. So I would take away P to get my P's on one side, and that would leave me 0.2P equals 1.6. Now this isn't very nice to solve with a 0.2 there, so I'll get rid of the 0.2. The other way to get rid of a 0.2, by the way, is to times by 5, which would turn it into a 1. Might be easier to do. It's the same thing as dividing by 0.2. Okay, and that will give me P equals 8. Okay, quite tricky that last question. Took me a little while to think about what to do. And the last one, the grade 8-9 challenge. This is actually an exam question. Well, I can't remember where from. We've got two triangles in the diagram and they are similar. There are two possible values for x. I'll show you why. Work out each of these values. State any assumptions you make in the working. Alright, well these two triangles are similar. Well, one is inside the other. We know that this angle in the smaller triangle is the same as this corner angle in the larger one. But we don't know whether this side here corresponds with AC, that side, or whether it actually corresponds with AD. Okay, because if you think about it, it doesn't have to, this triangle doesn't have to sit the same way up as this larger one does. You can imagine flipping it over. Okay, so it could look kind of like this, although drawn better. Okay, so they purposely drawn it not quite looking the same. If it was sat the same way around as the overall large triangle, then these two sides would be parallel. Okay, right. So if 8 does correspond with this AC, okay, so let's just put if AB corresponds to AC, then 8 times the scale factor is equal to 8 plus x. That's what we can call the length of the overall side. And 12 times the scale factor would equal the overall length of this bottom one. Okay, so that would be 15. And we can work out the scale factor from this. So what would I times 12 by to get 15? I would times it by 1.2. Sorry, no, 1.25. So that would enable me to work out this top bit. So if I go back to doing this up here, 8 times 1.25 would give me 10. So we're saying that 10 is equal to 8 plus x. So therefore x is 2. So that's one value of x. Now let's assume that AB doesn't correspond to AC. Excuse my handwriting. It's not easy on this. Let's assume it corresponds to AD, this length down here. Then we know 8 times the scale factor would be equal to its overall length, which is 15. And straight away from that we can work out what the scale factor is. So that would be 15 divided by 8, and that's not a very nice number. So what's that? 1 7/8, if we want to use a decimal. Sorry, 1.875. Being completely mixed up. Okay, so then this one, this 12, would correspond to this side AC. So 12 times by the scale factor, and I know the scale factor now, it's 1.875. And that would be, what would that give me? It gives me 22.5, which is equal to 8 plus x. So from that assumption, x is equal to 14.5. Okay, so there's our two possible values of x. Well done if you've understood that.